So, here's my lightning talk about JuMP and HiGHS, delivering the best open source linear optimization solvers. Currently in JuMP, in open source linear optimization, JuMP supports 30 open source solvers. All of them can solve linear programming problems, and most can solve quadratic programming problems. But only 4 can solve mixed integer programming problems: HiGHS, skip, CBC, and GLPK. So why did JuMP want to support HiGHS? Well, 3 real reasons. First of all is its performance. Secondly, the fact that HiGHS is actively supported. And thirdly, perhaps, HiGHS has a very permissive license. So, what is HiGHS? It's open source software for large-scale sparse linear optimization. First of all, the name. This comes from the initials of the original contributors: me, Yvette Galabova, Chi-Hang Fu, and Lukas Schork. To these two we add Michael Feldmeyer and Leona Gottwald, and Yvette, Leona, Michael and I are the current team. HiGHS features simplex and interior point solvers for linear programming problems, a branch and cut solver for mixed integer programming problems, an active set solver for QP problems. It's written in C++ and has interfaces to other languages and systems. It's available as open source under the MIT license. It contains no third-party code, and further details can be seen on our website. And in terms of performance, it's the world's best open source linear optimization software. The project itself began with the integration of Yvette Galabova's pre-solve and Chi's dual simplex solver back in 2016. We created the name 2 years later, and then Yvette integrated Lukas Schork's interior point solver in 2019. Michael Feldmeyer has been developing his active set solver since 2018, and the new MIP solver and LP and MIP pre-solve has been developed by Leona Gottwald in the last couple of years. In terms of our interaction with JuMP, well, the first interest in HiGHS was expressed by JuMP in 2019, and the JuMP in HiGHS interface was developed by Oskar Dowson and Yvette Galabova in 2020. The JuMP team's been very, very helpful to HiGHS, and in particular, JuMP now maintains the HiGHS binaries, and HiGHS has become the default solver in JuMP documentation over the last couple of years. Here's the performance of HiGHS relative to the best commercial solver and other open source solvers. For simplex, the performance of the codes is normalized so that the best solver has a speed of 1, and that's Cardinal's simplex solver written by Chi. CLP is John Forrest's code, which is slightly faster than HiGHS, and behind that we have Google's GLOP, the simplex solver in skip and GLPK. For interior point methods, again, the best in the world at the moment is Cardinal's interior point solver written by Lukas Schork, and behind that we have Google's new first order method solver, which is noticeably faster than HiGHS interior point solver, and behind that come Tulip and CLP. However, the Google interior point solver and Tulip have no crossover. For mixed integer programming, the best code is still Gurobi, but HiGHS is the best of the open source solvers by a margin in terms of problems solved within 2 hours. Next, behind that comes skip, and then CBC, and a long way behind is GLPK. The future of HiGHS is secure in terms of support. The School of Maths has identified what we're doing as being of high quality and employs Yvette Galabova as Integration and Development Manager and Leona Gottwald as the MIP developer. The presence of HiGHS is growing over time. We have an increasing number of tools for which there is an interface to HiGHS. And in the longer term, we're looking to expand the HiGHS team. We're looking to develop a Cholesky-based interior point solver and then develop new solvers in nonlinear optimization. One question underlying all this is how we fund it. My time may be free since I'm employed, but how do we fund everything else? Well, one thing which has happened recently is that HiGHS has been identified by the energy system modeling community as being the missing link for a fully open source ecosystem. PIPESA is an open source energy system modeling project for small institutions. It has an open data and modeling, and it needs an open source solver. The PIPESA models are linear programming problems, and the team was trying traditional open source interior point solvers and finding that they were very, very poor relative to Gurobi. Then they tried HiGHS and noticed that for their smaller models, HiGHS was pretty much keeping pace with Gurobi and leaving the other open source solvers behind. So HiGHS offers hope for the PIPESA project to solve truly open source problems of meaningful size. For larger instances, HiGHS was within a factor of 10 of Gurobi in most cases, but for some, it's unacceptably slower than Gurobi. So our aim is to bridge the gap to Gurobi, and to achieve that, we've set up a crowdfunding campaign that so far has raised $80,000, but we expect it to raise considerably more in the next few months. So that's HiGHS: high performance linear programming solvers, MIP solvers, prototype QP solver, many language interfaces and application interfaces, permissive license and no third-party code, available via JuMP.